Okay, so let's give this a try. Right. So as I was saying, we have this set of loans or borrows that are in scope at any point, and we're going to compute. They're going to come. They basically come into scope at the point where you make the borrow or make the loan, and then they go out of scope roughly when the last use is, right? Depending on the precision of the analysis. But for here, it would be here. In this example, it would be here. And the idea is we only store, the way that the data structures are set up, we only store the set of loans at each point, or at the beginning of each basic block, we store the set of loans that are in scope there. So there would be like nothing in scope at the beginning of B0 and one thing at B1. Right? And then what we do is we iterate over each basic block. We load the set of loans as well as paths that are moved and other stuff. We load that up at the start and we adjust it as we walk through each statement, taking things in or out. So we might start out with L0, then we would say, okay, before we enter this statement, it's the same as the beginning of the block, because nothing happened yet. And then when we enter this statement, nothing happens that affects the set of loans. But when we enter this statement, we will have removed L0 because it's no longer in scope.
So this is what you would call like the middle of the basic block.
The what?
We're talking about the beginning and there was the middle and the end of the loan, something like this.
Yeah. The middle. Oh, you mean the mid and the start points or whatever?
Yeah.
Yeah, we don't have that concept in this bar checker today per se. We don't keep a start and an end. We just look at each statement, but it effectively works out like that. Yeah. So the midpoint is sort of, or the initial value at any given point is the start, and then we make changes, and that's kind of the midpoint. And all the errors, when we're reporting errors, we only ever really care what's in scope when the statement starts, actually. So if we look in the code, let me kind of show you. Well, you don't have to see the mechanism that adds and removes things is not like I can't easily show it to you. It's basically what's driving this. It's going through the mirror and it's giving you a callback at each spot, and in between callbacks, it's adjusting the set. So that's why this code just says, give me the borrows in scope, and it means like right here at the point where you called me back. You know?
So when we are at the mirror, we are already in a linearized state, right?
Yes. And actually this context variable here, this one, is there a way to jump to definition here?
GD, go to definition.
Okay. So if you look at it, the context kind doesn't matter too much, but you see it has a location.
Okay.
That's the current spot also. So the borrows in scope method just knows implicitly what the current location is, but if you need to know it, and we will, it's there.
So this is kind of like a frame pointer.
Yeah, it's the current location, right? So it starts out as, it's always the pair of a basic block and an index, right? So at this point it would be B10, and here it would be B11, and here
okay.
B12. How do I jump back now?
Ctrl-O.
Okay, so, right, so each borrow involving path, that's a helper function that gets called at various spots. So let me give you an example. So, it's kind of got a lot of layers. I'm going to try to find the top one for a second to sort of walk you through, but just for context. So basically, we get these callbacks. Where is it? Yeah. So we get these callbacks. I told you it's something's driving us and calling us back. This is the callback spot. There are actually two, but this is one of them. And this is saying, okay, you're at this statement. Your flow state, that's this one, is up to date for entry to that statement right now. And you notice we have a shared borrow. We can't mutate it. We can just read it. And here's the location where you are. And here's your statement. Now, report any errors that are appropriate, basically. Right? And so, for example, if we're assigning to a path, so that would be like x equals y, right? Then we call this function mutate place, and we give it the left-hand side. That's what LHS is. So that's the path we're assigning to. So if we have x equals y, that would be x. Right? And this function, mutate place, is going to check if x is borrowed, and if so, it's going to report an error. So that would be like, if here we said x plus equals 1 or something, or no, it's actually y that's borrowed. If here we said y equals 1, this would be an error. So we would get a call to access place for y with a mutable access, and we would see, L0 is in scope. L0 borrows y, error. That makes sense? Let's replace this statement print with y equals 1 so we get it.
Yeah, I'm just trying to see where's the UI.
What? This is y here.
Yeah, but why it's borrowing UI?
Well, because here.
Oh, no, yeah, forget it. Now I see the UI there.
Yep. Okay.
I was just thinking too much on X.
Yeah, it's a little. Maybe I should have picked better variable names, but anyway. Yeah. So in this case, y. So that it's not too important to go into details, but all that stuff gets reflected here, right? Like the mutate mode will. There are different modes. If it's plus equals or just equals, makes a difference.
So when we say place, here we are saying like one line into the basic block.
No, actually a place refers to a path. Like it's a memory place, a place in memory. So y is a place in memory, the variable y, but also y dot f, if it had a field f, is a place. It's a sort of narrower place. And star y is also a place. Basically something you could assign to, also called an L value. But place is our friendly term for L value, because people were getting confused with that term. So, and we used it to mean like 3 different things. So anyway, what does this do? So this is so mutate place is called when some place in memory is being mutated, and it basically its job is to report an error if that mutation would be illegal, right? And that actually calls a more general helper called access place, which says some place in memory is being accessed in some way. Could be reads, could be writes, could be both. And that, let's see, blah, blah, blah. So this code here, this first set of code, this is just suppressing duplicate errors. This check access permissions, that's kind of a basic check that says, like, you have a variable that's not declared as mute, then you can't mutate it. Like it's a simple, there's no special flow sensitive state needed for that. But the most interesting part is check access for conflict. So this method is saying we're accessing a path, let's check if it conflicts with any of the borrows that are in scope. And finally now, we get to this helper, each borrow involving path. And what this does is it invokes this closure for every borrow that involves that path. So it goes over all the borrows that are in scope, all the loans. It checks what path they borrowed, and then it checks the path being accessed. If they're not the same, or they don't overlap, then it ignores it. But it'll call you only if there's an overlap. And then we basically report an error. There's some extra code here, but mostly this is figuring out sort of what kind of error to report. But all these reports.
So this is the thing that is responsible for the nice, friendly messages that we get.
Yeah. But basically, more or less, each time we invoke this function, it's probably an error. And so let's look at this each borrow involving path, because this function is the one we're actually going to modify. So all it does, or it goes over the flow state. So this is that set of loans that we computed. It finds the set in scope. This gives you back an index That's what I is. It's an index into like L0, L1. And then we look up the data about that loan. So the borrow set has all the loans, and you can index it with a borrow index. And we check, this is a kind of complex function, but it ends up basically saying, do these two places overlap? So like two different variables don't overlap, but x.f and x do, and so on. Right? So what we can do now, basically, this exact function here, now I'm going to switch to my diff and show you what I changed. This all makes sense so far? I assume you would interrupt me.
Yeah, I'm following so far.
So, yes. So this is that code we were just looking at. But you see the minus. I took away, instead of iterating through the borrows in scope, instead I have these two lines here. The first one says let location index equals self.location table, that one. I don't have a good cursor. Maybe I can like pop this into DI or something. I cannot edit standard input. Oh, shut up. Let's try this.
Envin. Need to fix my aliases.
Yeah. Okay. Right, so as I said before, this patch actually removed the old code. I think we want to keep the old code to have two modes. But anyway, so in this function, we're iterating over the
So this is where we will check for the flag, the command line.
Yeah, or we might have a helper function that does it, but yes, at roughly this spot. So you probably can't quite integrate it. Well, I don't know. We can discuss after exactly how. But what I did in this patch is I added a field to the borrow check context, and that's this live borrow results. That's the output from Polonius. So now this would be output instead of live borrow results. And it's in an RC, so I'm just putting on the stack here.
So one thing that I wanted to understand is where the Polonius data comes. Like in this case, where this field will be populated.
Yeah, and that's probably roughly the same as what's in the path. Let's take a little excursion to look at what I changed. So first of all, I added this field to the borrow check context, which is basically the self for all these methods we're looking at. And then it's annoying. Okay, so you remember we were looking here in this do mirror borrow check. I was showing you that it computes it calls the NLL compute regions, and then it does this data flow for the borrows, and then it creates this mirror borrow check context and analyze results. That's the call that invokes us and we report errors. That's basically where all the magic happens. So the way this works in this code, I don't know that this is how we want it to work exactly, but is that the compute regions still does the old analysis, but it also does the new analysis and returns a third thing. You see, our disclosure got 3 things now, or this tuple. And that's the data fraud results, basically, or Polonius results. And then we take those Polonius results and we store them in the mirror borrow check context. That's an okay place for them to go. I think we might want to put them actually in this flows data structure, but we can go into that later. It depends how we do the switch. But basically that's, so roughly where we do the region computation now is where we want to run Polonius in the new version. And you can see in the code, we'll go back to it later, we're gathering up the facts and stuff that Polonius uses as input. So that's kind of the same point where we write the facts to disk is kind of the point where we could run Polonius because all the facts are there. So let's take a look at how we use this field now. So now we have this live borrow results. This is the output. This basically tells us for any given location what borrows are in scope. And so we replace, oops, this is one of the corner cases I don't want to talk about yet. Go to the common. This is the normal case. that we were looking at, instead of calling flowState.borrowsInScope, this works a little differently. We call this method borrowsInScope@, and we have to give it a location. So the flow state that we have before kind of implicitly is being updated in place with our current location, but the results from Polonius are just for all locations, and we give it the one we want, and it looks it up. And so we
So
find
this context block is actually incrementing monotonically, even over different basic blocks, or we have several live borrow results for basic blocks.
This context.loc, this is just the location. So it'll be like, which statement are you at? BB1/2 or something, right? And then when we call start index, that gives us the point start of that statement. So if you remember in the blog post, I made that distinction. So we're saying, what are the borrows at this point where the statement starts, before we've done anything? And then we call borrowsInScope, and we get this set of borrows, and we can iterate. It's just it's the same borrow indexes that we, like where we used to have we now have, I renamed it, but it's the same variable. And then we can index the set the same way we did before. These two lines are the same. Nothing, like nobody else cares, right? At this point, it's the same. All the old code still works. We probably can do this more efficiently, but this is the easiest way to wedge it in. The only difference from here I'm iterating over borrowsInScope, but in Polonius, we have a different field called errors, I think, in the output. And that's even better somehow, because actually we're kind of guaranteed that this check places conflict is going to be true. Hi, Daphne. I just want to say hi.
Hello.
You want a hug? Oh my gosh. That is fun. I'll come down and see you later, okay? Bye. So actually Polonius is already figuring out that the places conflict, but so what? So we check again, it doesn't matter.
Yeah, that's nice because we can potentially, once we can confirm that Polonius is doing the right thing, we can even eliminate this part, right?
Right, then we can start to do some optimization. Yeah, exactly. And in fact, we can do even better. We don't, like here we're walking over the whole mirror, but Polonius already figured out all the spots that have errors. We don't have to walk over the parts that don't have errors, who cares? The only problem with that is Polonius doesn't yet have the full borrow check in it, so we still do have to, like it doesn't handle moves and stuff like that. So until we move everything, we still have to.
So what Polonius is handling now, if it doesn't handle moves, it's only like the borrows?
Just the borrows.
Okay.
That's kind of the hardest, most expensive part. But there's no reason we can't do it all, as far as I can tell. It just takes some work.
More data log.
Yeah, exactly. So, right, so basically this is what we would do. I think the reason I said we might want to store the output not in the borrow check, like I did, but rather in the flow state, is so that we could even put it in this method, right? So we just call borrowsInScope. Maybe we pass in the location here, context.loc, just because it's easy. But in that case, then it checks internally a flag and uses Polonius or uses the other version, depending on the borrow checker proper doesn't care. But there's one, maybe we do it there, but there's a reason I didn't. Let me show you the other case then. Because that was my original plan. But there's a kind of funny, well, actually, let's check two things. First of all, is there other code? This is the code we were just looking at. Yeah, okay. Sorry, I just want to make sure I'm coming. This is the code we were just looking at. Yeah, okay. So there's one other place where we do iterate over the set of borrows. Actually, two. It's going to be an entertaining recording. So, actually, I think the video is not on it.
Well, I still see you, but
Yeah,
whatever.
you see me, but the recording only has this monitor, which doesn't have.
Oh, gotcha, yeah.
So
Less work, the edition work for you.
I, so so yeah, the with outgoing borrows. Right. So the flow state has the borrows in scope. That tells you the borrows on entry, but it also has with outgoing borrows, and that tells you the borrows after the statement. Like basically the borrows that are in scope at the start of the next statement.
So in this case, the borrow that we have on at the end of B0 before the goal, after the goal, kind of like the goal 2.
Right. So if you look at the document on line 17, uh, if we call borrows in scope, we would get a set with just L0 in it. If we call with outgoing borrows, we would get an empty set. But the Polonius doesn't have this concept because it doesn't have a notion of location. So I just translated that code to like find the location of the next statement and ask me for the borrows there, right? It's the same thing, only nicer, basically. So in one case, so that's what this, what is this? Sorry, I'm just remembering what this is. Well, no. Yeah, so there are actually a couple places we call with outgoing borrows, and I did different things depending, two of them. So in one case, this is like a generator yield for async await and all that stuff. In that case, I find this point resume, that's the basic block where the generator starts back up again. So instead of asking for the outgoing borrows, I just ask at the resume point, what are the borrows? Because that's what we care about. And in the other case, this is a return. What this is doing is saying when you return, there shouldn't be any borrows left of local variables because those are all going to be popped now, so that would be bad. And it's kind of an extra check. We normally catch this earlier, but there's some paths where we don't, and so like in unwinding and so on. And so this actually just checks for at the point of the return what borrows are still in scope. That's good enough. You don't have to look at. I don't know why it was with outgoing borrows in the first place. Actually, I think it would be fine either way. But so yeah. So what we basically want to do, if we add, we can go one of two ways. Either we modify the code sort of like I did here, which means we add a flag to the mirror borrow check context that says maybe the flag is just it has an optional Polonius output, and if the option is sum, then it uses it. Otherwise, it uses flow state. But the point is, we can these three spots that I showed, we could modify it to choose which version to use, or we can modify flow state, and it has two methods. With the borrows on entry and the borrows on exit, basically, and it can choose when you call those, we can do the right thing. And then borrow check doesn't have to know. I guess modifying flow state is sort of more elegant. I don't think it matters too much.
Yeah, it's more elegant and probably easier to reason than this.
Yeah, it seems a little cleaner. So that's a slightly
So
different.
let's write this down. So essentially, we want to change flow state.
Yeah. And I think, so it currently has these two methods. It has borrows in scope and with outgoing borrows. And I actually added these methods, well, they were sort of there before, but I introduced them in anticipation of doing this refactoring. They used to be a little different. I think we want to add, though, one thing I would say we probably want to change is we want to add the location so we have to add the location somewhere. We have to track the current location. You could add it as a field in flow state. The reason that would make sense is that it already is sort of tied to a location, so why not? However, I think that was a little awkward when I looked at it. So another option would be to just have them take a location. like current location.
Well, we have the location readily available.
Right, we have it readily available, so that's okay. You know, and basically, you would just pass it context.load. That's the easier change. It's probably what I would do, at least to start. You can always do factor later.
So the first thing I need to add the flag for polonius.
Yes, of course.
And where I'm going to expose this to this.
So yeah, first add the -c polonius flag. Then the question
This
is
is going to be inside the mirror context.
Let's look and see how the code works today. Oops, I'm shifting the wrong window. Let's see where. I want to see where the facts stuff is. I sort of forget.
You're on the wrong file. It's under NLL.
That's so annoying. Whose idea was it to change that?
And you went to the wrong file again.
No, it's the right file. It's just the wrong spot. Well, maybe it's the wrong file, but that tells me something. Okay, so I think the only... How do you use ripgrep in this thing? Is there a nice way, or do I have to just go to command?
Oh, you can use the standard grep, just G, capital G, grep.
Alright, it doesn't matter.
Yeah, that's your derived file.
I'll do this. So, right, so here's where we're making the facts. And here we're mutating the facts, and here we're dumping the facts, right? So I think basically right here I would call polonius. And then we arguably, I guess it's useful to keep polonius flag distinct from the NLL facts flag. You could imagine just having one flag, but you might want to dump the facts without using the. So anyway, but basically right here we would say something like, you know, or probably we would do something more like, you know, let polonius output equals
Okay.
we could use map.
This is nice.
Something like that, right?
So why are you exactly mapping? This is like a huge vector.
No, really, this would be and then. Don't have to use map, but when you invoke map or and then on an option, it basically says if this is sum, you can think of it like a one-element vector. If this is sum, I'll call the closure and let you change it, and if it's none, I just give none back. I actually usually don't use helpers on options, but rather just write the code because it's not so long and it's more obvious what's happening. But I don't know why I got queued here. But you get the idea, in any case. The only catch would be, one other thing is up here, you see that we only compute the facts if the NLL flags is true. We probably want to say or use polonius.
Okay.
And then similarly down here, you know, if dump facts. I don't know. Anyway, you can get the logic right. Something like this.
This is highly useful.
So then you'll have the output, and we'll return it. And this this will look like, I would probably put it in RC somewhere along the line.
Any specific reason? I mean, how this thing was single threaded?
I mean, the reason I would use an RC, I don't really care if you use an RC or an ARC, but the reason I would use one of those is that it's read-only, and that way we can just clone it wherever we want. It doesn't cost anything.
Yeah, that's fair enough.
So, it doesn't have to be. Then, so if you do this, I'll just save that. Then now you have the data, and you have to put it in the flow state. So invoke the polonius engine, and then give that output the option polonius output to the flow state. I mean, it already takes a whole bunch of parameters. Take one more. Yeah, if you do this, it should just work. Done.
Famous last words, right?
Yeah. I mean, I think that's
Rust changed my conception on this. Usually when you say you just need to set done and then it compiles and of course it fails in production, but when it comes to Rust, if it compiles, probably is right. It's awesome.
Yeah, yes. It's certainly right a lot more often. I think this is all you need to do.
Awesome. Yeah, I'm going to have fun with this for a while.
I'll be around for the next hour and a half or so you can ping me.
Yeah, I'm working on this now. One thing that I kind of wanted to check is anything of this like something that we can potentially split? In a sense, because Santiago was kind of trying to prepare.
I don't know how we're gonna. This feels like something that has to be done. I mean, you could imagine stopping here, right? This is like a midpoint where it's consistent. You've done the computation. You're just not using it yet. You could even add.
It's probably to find another task for him.
I don't think it's worth it. One interesting side task, which I think is worth doing, and you'll notice these diffs also in my PR, is integrate this output into the mirror dump. So if you look in my diffs, oopsie, wrong key. I have my, whatever this is, I have my screen set up to use Control Z and not Control A, so my fingers are off.
Control Z. That's even funnier.
It's like I never use that, or very rarely do I want to put the current process to sleep. But anyway, if we go down to mirror dump, wherever that is,
maybe it's another commit.
No, it's in this one.
Dump.
Okay. So this is the other set of changes I have is kind of
you put the live borers
passing it in, and then in this code it happens unconditionally, so this is not an option. But and then you can kind of, I don't know, I must have indented this so all these diffs are a little exaggerated, but I added all this extra stuff, right? So it goes through, for each statement, it goes through the start and the midpoint of that statement, and then writes out these are all the fields of the output, right? The borrows in scope, what's restricted, what's the subsets are there. That would be useful. I promise you we will want this information. It's basically how you debug what happened. So that would be a separate task. It's probably a follow-up task, but it can start.
One thing that I was kind of like we're having some like one of the things that I was going to ask is how do I validate that this if I have done this technically should work. So how do I see that? So it's kind of those players with that. Sorry. It shouldn't break anything.
You might see, basically all the tests should pass. What you might see is some diagnostic changes, like it's reporting errors slightly differently, but if you see any case where it's not reporting an error and it used to, or vice versa, then that's probably a red flag. The only difference is there's one or two tests I would expect to pass now that do not. Like this analysis is better, so I would expect some tests to pass.
Yeah, in this case, I have to pass the.
Yeah, in this case, I have to pass the zip flag
yeah,
to the test.
No, yeah.
Oh no, yeah.
You actually pass the flags inside the test
You actually
file.
pass the flags inside the test
can,
file also,
but
right?
I don't know if there's a way. I think maybe you can. I don't know if there's a way to set the flags. Maybe you can do rust flags or something.
Yeah, I'm going to investigate.
Yeah, I'm going to
Not sure.
investigate.
We might want to add another
Because my
mode.
concern is that the tests.
Yeah, because my concern is that the tests
specific
that were like
tagged
NLL
as
specific were
Yeah,
tagged
so
as
usually what I was
NLL.
doing, I of course had it unconditionally integrated. I was just running the XPY test, source test UI or something. But I think we have this compare mode called NLL. We could probably add like polonius or something, and it's just a line or two somewhere in the source. You can find it if you search through the source tools wherever the testing harness is. I can show you later. The main thing is there you can easily tell it what flags to pass. So it could pass. We can just add -c polonius to the list. The only problem with that will be we also would want to go and rename all the .nll.standard error files to .polonius.standard error because that's the expected.
Kind of makes sense.
Yeah.
But that's where we want to go, right?
Kinda
Because
makes sense.
NLL is kind of.
But that's where we want to go, right? Because NLL
Well,
is
it
kind
kind of
of
says what it is, but not necessarily.
well, it kind of says what it is, but not necessarily what we